Hello everyone. Um, we reached this point where we are now trying to calculate how logit's variable impacts the loss. So if you see logit's two ways impacts the loss. One, it first impacts logit maxes, and the other is it again impacts the value of norm logits as well. So it's two-way that it's impacting loss, one via logit maxes, one via norm logit. So what we will see is first will be how logit impact logit maxes, and then how logit maxes impact loss, the chain rule. Then next is how logit impacts norm logits, and then how norm logits impact loss. Okay, so that's what I'm doing here. Norm logits plus, sorry, and then how norm logits is impacted by the logits. This is one way to do that. The other way is how loss is impacted by sorry, which one I took? Norm logits, right? So we'll now take logit maxes. So how loss is impacted by logit maxes, and then how logit maxes is impacted by logits. So these two will calculate. So first let's go ahead with this. Okay. So this, right, d loss by d norm logits, that's already calculated. That's here. Okay. We'll try to figure out this one. Okay. So norm logits is logits minus logit maxes. Maxes by d logits. This will be 1 because this will get differentiated based on d logit, so that will be 1, and logit maxes uh, okay. D-logit maxes. Does this impact D-logit maxes? Yeah, it does. Mm. So we can't say it as 1 because it will be 1 minus D-logit maxes by D-logits. And we see that logit impacts logit maxes. So we need to calculate this first. D-logit maxes by D-logits. So what's happening here is in this 2D array that we have, right, the output that we are getting here, for each of the rows we are trying to calculate the maximum. Okay, and we are trying to calculate the differentiation of that based on logits. What is the differentiation? I think if we have, say, that row, I'm taking it as an array, right? If we are changing the value all by 1 and we are differentiating based on that, the value should increase by 1. So for me, that should be 1, is my belief. With respect to, let's see, oh, sorry. The way I was saying, one was if all the so when I see this array, right, with respect to this, so if increase by 1, I mean all the values increase by 1, the maximum also increases by 1, right? Because 5 will become 6 and that will become the maximum. So the derivative should be 1 is my belief. So this should also come as 1, which makes it as 0. So that was this thing. Let's see. We'll see what Andrew Karpati does. And this one, right? So this one we already calculated. Mm, 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 mm. This as 1 now itself we calculate, so we can remove all of this and make it like so d loss by denorm logits. So d loss by d norm logits. So this is the d norm logits that is already calculated. This we figured out. Actually, it's I forgot. So this is 0. So it makes this whole as 0. So it comes out 0. I don't think so. It's correct. Okay, let's see.
Let's comment out the comparison and let's make sure, crossing fingers, that we have the correct result. So PyTorch agrees with X. Here, basically implement the replication. You can look at it that way. Earlier here. And that was just the first branch, and we're now finishing the second branch. So we need to make sure that these gradients add. So plus equals. And then here, let's comment out the comparisons on this gradient as well. Okay, hopefully we're getting a hang of this now. Counts as an element-wise exp of norm logits. So that's so norm logits has the shape 32 by 27. Logits does as well, but logit maxes is only 32 by 1. So there's a broadcasting here in the minus. Are 1 for the corresponding A, and it's a -1 for the corresponding B. And so therefore, the derivatives on the C will flow equally to the corresponding A's, and then also to the corresponding B's. But then in addition to that, the B's are broadcast, so we'll have to do the additional sum, just like there is. So let's just, so D logits equals D norm logits, and I'll do a dot clone for safety, so we're just making a copy. And then we have that D logit maxis will be the negative of D norm logits, because of the negative sign. And then we have to be careful because logit maxis is a column. And so just like we saw before, because we keep replicating the same elements across all the columns, then in the backward pass, because we keep reusing this, these are all just like separate branches of use of that one variable. And so therefore we have to do a sum along one with keep them equals true, so that we don't destroy this dimension. And then D-logit maxis will be the same shape. Now we have to be careful because this D-logits is not the final D-logits, and that's because not only do we get gradient signal into logits through here, but logit maxis is a function of logits, and that's a second branch into logits. So this is not yet our final derivative for logits. We will come back later for the second branch.
Okay, what does happen? Okay. Oh. Need to listen this a bit.
Let's just implement that. Basically, of course, to that. And so therefore, and every and so for example, every element of C, we have to look at how it came to be. Every element of C is just the corresponding element of A minus basically that associated B. So it's very clear now that the derivatives of every one of these C's with respect to their inputs are 1 for the corresponding A, and it's a -1 for the corresponding B. And so therefore, the derivatives on the C will flow equally to the corresponding A's, and then also to the corresponding B's. But then in addition to that, the B's are broadcast, so we'll have to do the additional sum, just like we did before. And of course, the derivatives for B's will undergo a minus, because the local derivative here is -1. So dc32 by d b3 is -1. So let's just implement that. Basically, d logits will be exactly copying the derivative on norm logits. So d logits equals d norm logits.
let's go back.
Already calculated. We calculated earlier here. And that was just the first branch. And here that we have the correct result. So PyTorch agrees with us on this gradient as well. Okay, hopefully we're getting a hang of this now. Counts as an element-wise exp of norm logits. So now we want to denorm logits. And because it's an element-wise operation, everything is very simple. What is the local derivative of e to the x? It's famously just e to the x. So this is the local derivative. That is the local derivative. Now we already calculated it and it's inside counts. So we might as well potentially just reuse counts. That is the local derivative. Times d counts. Funny as that looks. Counts times d counts is the derivative on the norm logits. And now let's erase this and let's verify, and it looks good. So that's norm logits. Okay, so we are here on this line now, denorm logits. We have that, and we're trying to calculate d-logits and d-logit maxes. So backpropagating through this line. Now we have to be careful here because the shapes, again, are not the same, and so there's an implicit broadcasting happening here. So norm logits has the shape 32 by 27, logits does as well, but logit maxes is only 32 by 1. So there's a broadcasting here in the minus. Now here I tried to sort of write out a toy example again. We basically have that this is our c equals a minus b. Toy example minus logit maxes is only 32 by 1. So there's a broadcasting here in the minus. Now here I tried to sort of write out a toy example again. We basically have that this is our c equals a minus b. And we see that because of the shape, these are 3 by 3, but this one is just a column. And so, for example, every element of C, we have to look at how it came to be. And every element of C is just the corresponding element of A minus basically that associated B. So it's very clear now that the derivatives of every one of these C's with respect to their inputs are 1 for the corresponding A, and it's a -1 for the corresponding B. And so therefore, the derivatives on the C will flow equally to the corresponding A's, and then also to the corresponding B's. But then in addition to that, the B's are broadcast, so we'll have to do the additional sum, just like we did before. And of course, derivatives for B's will undergo...
So d-logits will take the derivative of denorm logits. Logit maxes anyway, it's
a minus, because the local derivative here is -1. So dc32 by db3 is -1. So let's just implement that. Basically, d-logits will be exactly copying the derivative on norm logits. So d-logits equals denorm logits, and I'll do a dot clone for safety. So we're just making a copy. And then we have that d-logit maxes will be the negative of denorm logits because of the negative sign. And then we have to be careful because logit maxes is a column. And so just like we saw before, because we keep replicating the same elements across all the columns, then in the backward pass, because we keep reusing this, these are all just like separate branches of use of that one variable. And so therefore we have to do a sum along one would keep them equals true, so that we don't destroy this dimension. And then d-logit maxes will be the same shape. Now we have to be careful because this d-logits is not the final d-logits, and that's because not only do we get gradient signal into logits through here, but logit maxes is a function of logits, and that's a second branch into logits. So this is not yet our final derivative for logits. We will come back later for the second branch. For now, d-logit maxes is the final derivative. So let me uncomment this CMP here, and let's just run this. And logit maxes if PyTorch agrees with us. So that was the derivative through this line. Now, before we move on, I want to pause here briefly, and I want to look at these logit maxes and especially their gradients. We've talked previously in the previous lecture that the only reason we're doing this is for the numerical stability of the softmax that we are implementing here. And we talked about how if you take these logits for any one of these examples, so one row of this logits tensor, if you add or subtract any value equally to all the elements, then the value of the probs will be unchanged. You're not changing the softmax. The only thing that this is doing is it's making sure that X doesn't overflow. And the reason we're using a max is because then we are guaranteed that each row of logits, the highest number is 0. And so this will be safe. And so basically what that has repercussions. If it is the case that changing logit maxes does not change the probs and therefore does not change the loss, then the gradient on logit maxes should be 0, right? Because saying those two things is the same. So indeed, we hope that this is very, very small numbers. Indeed, we hope this is 0. Now, because of floating point sort of wonkiness, this doesn't come out exactly 0. Only in some of the rows it does. But we get extremely small values, like 1e negative 9 or 10. And so this is telling us that the values of logit maxes are not impacting the loss as they shouldn't. It feels kind of weird to backpropagate through this branch, honestly, because if you have any implementation of like f.cross-entropy in PyTorch and you block together all of these elements and you're not doing the backpropagation piece by piece, then you would probably assume that the derivative through here is exactly 0. So you would be sort of skipping this branch because it's only done for numerical stability. But it's interesting to see that even if you break up everything into the full atoms and you still do the computation as you'd like with respect to numerical stability, the correct thing happens. And you still get a very, very small gradients here, basically reflecting the fact that the values of these do not matter with respect to the final loss. Okay, so let's now continue backpropagation through this line here. We've just calculated the logit maxes, and now we want to backprop into logits through this second branch. Now here, of course, we took logits, and we took the max along all the rows, and then we looked at its values here. Now the way this works is that in PyTorch, this thing here, the max returns both the values and it returns the indices at which those values took on the maximum value. Now in the forward pass, we only used values because that's all we needed. But in the backward pass, it's extremely useful to know about where those maximum values occurred. And we have the indices at which they occurred. And this will, of course, help us do the backpropagation. Because what should the backward pass be here in this case? We have the logis tensor, which is 32 by 27, and in each row we find the maximum value, and then that value gets plucked out into logit maxes. And so intuitively, basically the derivative flowing through here then should be 1 times the local derivative is 1 for the appropriate entry that was plucked out, and then times the global derivative of the logit maxes. So really what we're doing here, if you think through it, is we need to take the d-logit maxes and we need to scatter it to the correct positions in these logits from.
Okay. I think this is something like what we did in the log props here. We calculated the differentiation just based on those values, and for the others it was 0. So that's what I think this was also saying, that if you change an element except the maximum value, right, obviously the derivative is 0 because others are not changing, and if the maximum value changes by 1, the derivative is 1. So at that index, right, the derivative is 1, whereas all the other values are 0.
Where the maximum values came. And so
Okay, now I'm getting a bit of hang of it. So d-logits. Just a bit.
Scatter, we're doing and about values. Okay, so let's and you still get numbers saying that for
What will be so one thing? This part, right? We calculated it. So these two are already calculated. Okay. The thing that we need to calculate is these two. Okay. And internal to this, if you see, so logit maxes will have a differentiation. Okay. Not zero for sure. 1 minus that whole array will be differentiated. So that will be 1 minus that variable that he is saying. So this will get calculated and we have the value for this. I don't know why the logits should be equal to. Okay, I see a point what he's. But so I don't know if you have the thing that is happening is both are impacting this, but this is impacting this as well. That's what is happening, right? This is logits. You can say logit maxes. So we are seeing logit minus logit maxes. You can think of this as a negative. So this is logit maxes, but internally logits there is one more arrow to this as well. So one is for sure this gradient will follow here, and then this impacts this by the max function, so that gradient will also follow here. Okay, so at the end we should see no, but that negative sign, right? This what we had defined here in the microcrad regarding so the question that I'm getting is if there is a addition, right? Say addition. It is saying that for both, right, the out dot grad will come here. My only problem is what if there is a correlation between the two? Let me check. Um, let's keep it C equal to A plus B. So that is one part of it. That's what I was saying here, that if there is an addition, right, we just can't propagate this gradient to this here, because in that the case was that dA by dA is 1, dB by dA is 0 if there was no correlation. That's why you see a where it went. That's why you see a 1 here. Okay, right. So B, if you see, right, B is again an 2D array, and A, if it is not equal to 1, it is 0 0 0, it becomes 1 then 0, so it is a So that's will this gradient be calculated twice? Will this gradient be backpropagating? Let's see if this works out. I'm not sure. Let's see.
For now, dlogit maxes is the final derivative. So let me uncomment this CMP here, and let's just run this. And logit maxes, if PyTorch here, we've just calculated dlogit maxes, and now we want to backpropagate positions in is, okay, I apologize, this is crazy. PLT.im show of this. It's really just an array of where the maxes came from in each row, and that element is 1, and all the other elements are 0. So it's a one hot vector in each row, and these indices are now populating a single 1 in the proper place. And then what I'm doing here is I'm multiplying by dlogit maxes. And keep in mind that this is a column of 32 by 1. And so when I'm doing this times dlogit maxes
So that is this one that he's calculating. So this will be a one hot vector. That's what was explained here, right? That so dB by dA is a vector where each element is 1 if the corresponding element A is maximum and 0 otherwise. And then it gets multiplied with the logit maxes. I basically have questions regarding this individual. Won't the same thing happen here as well? It should. Let's see.
PyTorch that the dimension of every one of these tensors should be 27. And so what this is going to do is, okay, I apologize, this is crazy. PLT.im show of this. It's really just an array of where the maxes came from in each row, and that element is 1, and all the other elements are 0. So it's a one hot vector in each row, and these indices are now populating a single 1 in the proper. And keep in mind that this is a times dlogit maxes. Dlogit maxes will broadcast, and that column will get replicated, and then an element-wise multiply will ensure that each of these just gets routed to whichever one of these bits is turned on. And so that's another way to implement this kind of a operation, and both of these can be used. I just thought I would show an equivalent way to do it. And I'm using plus equals because we already calculated dlogits here, and this is now the second branch. So let's look at logits and make sure that this is correct. And we see that we have exactly the correct answer.
Okay, so one thing I see here, why that is working, and that's correct obviously, because this case, right, when this impacts this and this impacts this as well, when we calculate the gradient from this path, we calculate from this path, we also calculate. So twice it gets calculated. In that case, what's happening is this impacts this for sure, this impacts this as well. And ideally, there should be two calculation, one this one and the other this guy impacting this one, two gradients additions. Okay, so if while calculating this, right, obviously this, because it's addition or a subtraction, the gradient follows here, and this is separately calculated in a backpropagation. That's the understanding then here, if that works, right. So here, if there is addition or a subtraction, expectation is that we will take this as if there is no correlation between them, though they exist, because that will be taken care by this expression, the one that is putting here, right. So that will be taken care in that way. So have this understanding here that if, so that's why the um overall thing is one is DL. So this finally this will come out as DL by DC plus DL by DC into DB by DA. Okay, and this is what is, I have to take this out, right? So what I wrote here, right, is DL by, sorry, so DL by DC into DB by DA, that's what he calculated here. Okay. Because dV by dA will be this one hot vectors. If you remember here itself it wrote, right? Yeah. So the term is a one hot vector completely. That was this thing, and this individual is with respect to C. So that is what D logit max is. D logit max is DL by DC. And here also, if we are adding D logit maxes, that's no, no. Mm-hmm. Okay. So dc by dA will be 1 plus dB by dA. Okay, this dB by dA is a unit vector. So loss with respect to A will be dl by dc into dc by dA. dc by dA is so this will be all ones that you see in the vector. Here it will be a one hot vector. Um, each element wise there will be an addition of both of them, so you will see 1 1 1, then 2, then 1 1 1 1 1 2, then 1 1 1, like that you will see. And when it gets multiplied by dl by dc, that is 32 cross 27, we'll see element wise multiplication, but few of those will be multiplied twice. Getting a bit confused here. Okay, so at the end we are trying to identify the d loss by d logits, and that is what we are getting here. Okay, for the time being let's tell this as d norm logits and d logit maxes. These two have been calculated. Okay, if we break this down, this is d. Okay, and d norm logits by d logits is this. Okay, so if we come back here, right, like this will be equal to 1 minus d logit maxes by d logits. Okay, I'm talking about this thing here. Okay, so what will happen? We'll plug this in there. it as so that we are not confused. We will do denorm logits into and then let's take this and this here. So d logits. I'm just trying to open it up. Minus sign also comes. Okay. I just multiplied this with my 1 and multiplies this with this. So this is what we are getting here. I think I will reach that. Okay. So if you see here, right, we see this common among these two. So we can take that as a common weight. So this is first. Control V norm logits minus whatever this is. So this will become denorm logits plus d logit maxes. That's what the equation becomes. Okay. So what he has calculated here, I think this is the one that individual Gashpati has calculated. That is one addition that's happening. I think what wrong I'm doing is writing it like that. See, at the end of the day, we have to calculate dl by dc, okay, at the end of the day. In c is equal to a plus b and b is equal to max of. At the end, the intention is to calculate dl by dc, okay. Dl by dc, c is equal to a plus b, so he has defined dc by da, whatever is coming, okay. Dc by da is this, okay. Now dl by dc, he is saying dl, so dl by a, based on a we need to calculate, okay, okay, sure. So a is our logits here, okay. A is logits. um b, you can take it as max logit maxes, and the b is norm logits, okay. So okay, so this is c is norm logits, okay. A is logits, B is logit maxes. So whatever comes here, so what he is saying is, so whenever you multiply, this will come as, yeah, dl by dc. So this c is norm logits. straight away that gets added here. That's what he adds here. This is the norm logits dot clone. Okay, so that is the where it went. That is the first part. The next part is again we see multiplication of dl by dc by db by da. db by da is something, is the one hot encoding that he's doing here. Okay, this is the one hot encoding that he's doing here. And then into logit maxes. And that's where the main problem was, that it should not be logit maxes, whereas it should be norm logits. Let me calculate this then. I will see if that works. But this equation is anyway fine. dl by dc. But only thing is, these are all vectors. I So what I will do is I will just check if that works. So let me see. So D is D norm underscore logits dot clone. So this is the first part. Okay. Um, this part of the equation. C is norm logits, impact of this on the loss. Other is D logits plus equal to f dot one hot logits underscore max one dot indices. This anyway remains the same. So this anyway remains the same. What I am proposing here is denorm logits, right? num classes, sorry. Let's see. Else we need to dig in a bit deeper in terms of why that is not working. Mm. And if I do it as budget underscore, sorry, what was the name of that? I can make it like this, and that was denorm logits, right? No, logit max, sorry. Where it went, man. Okay, here it is. My God's grace, this is also wrong, so. Oh, but you see one thing, this is with this, okay? And if we can, oh, sorry, this is getting added here, right? Okay, got it, no issues. So let's remove this just to test. So with the logit maxes, it's working. With the norm logits, it's not. So from where logit maxes is gonna okay. So in that case, B is the logit maxes, right? Yeah. DL by C, that is the. So this is logics, this is max logics, and this is norm logics. How the loss is getting impacted is by two paths. One is via this path, other is via this. If we consider through this path, because there is a subtraction involved there, so this gradient flows here and it gets stored here. If we consider this path, then we need to calculate the differentiation of the impact of this on this, and then impact of this on the loss itself. That makes sense because that has already taken care of this path. So impact of this on this is the one what encoding that we get here, and multiplied by the impact of logic max on the loss. That's where the prediction. So we can think it in that way that this is the norm logics that is coming here. So gradient of this coming here. Okay. What I'm trying to do here is I'm just trying to create the same environment. So I'm just trying to create the same environment. So this runs. There is no so we should see this is just a diction extra. So here logics is and let's think this. We have two columns of logic and just then in place of max and tensors logics minus this is nothing to non-logics. So see what. So this is the non-logics, okay. So there are two parts to non-logics. One is obviously and if we want to calculate with respect to logics, right? Logics takes two parts. One is this part, and the other is this part. So in this equation that we are one is simple that because there is a addition happening, or we can say a subtraction in this. So there are two parts, this part and this part. So because we see an addition here, what we propagate this gradient here. That's what we want to add. Other part is this part. Other part is this part. Now, to calculate this value, right? Whatever the data is getting calculated. Just to make this clearer, but this became clear. So logics has two way to impact. One is by this, because there is an addition you see, the gradient of this comes here. That is one part. The next part is this part. Okay. That's where what is happening. Impact of this on this, and then impact of this on the previous. That we'll get from this. Impact of this on this we'll get from this gradient, and this is where this one hot encoding comes. So this is power of two, but this is max. Okay. Just think of this as a max variable, something is happening. This is max. So impact of this on this is this one hot encoding, and then the logic maxes, which is this guy, gradient of the logic maxes into this differentiation, and then here it's in the first part. So it is copying this gradient directly here. It's the addition. So that's one way we can back. So that's why this that we see right was I think that's where the thought process was changes to gradients, addition, and it's always has already been a long learning from 5 days separation.